Hi, my name is Sam Shark, and I'm going to give you a quick walkthrough on how to use the RES4LYF nodes. So first thing, what does RES stand for in RES4LYF? Well, technically it's Refined Exponential Solver, but in the spirit of Bongmath, it could also stand for Bong resin. So we have the Clown model loader here. This really is just an efficiency node. It's just for convenience. You can pick the model name. It could be the so-called UNet file, the diffusion file, whatever you want to call it, or it could be a checkpoint. If it's a checkpoint, you can pick use checkpoint clip, and it will load those parts instead. So it's relatively self-explanatory at this point. Just need to make sure that you're picking the right text encoders. You can sometimes get really strange errors, something about like an attention mask not being the right shape, like with flux, if you don't pick the right one. Like if you leave out the clip L and only pick the T5. But aside from that, it's pretty straightforward. This model sampling and advanced resolution node, this is just like any other model sampling shift. Only difference is that you have a couple options here. You have exponential or you have linear. Linear is a scaling mode that was specifically available for Stable Diffusion 3. The exponential scaling mode was something that came with Flux. I found that the exponential one is usually a little better with Stable Diffusion 3, but your mileage may actually vary a little bit. It's particularly good with image-to-image stuff. What it does is it spreads the steps out a little bit more from the big, broad composition aspect to the smaller, more detail-oriented parts of the image. They encode advanced. This really is not actually advanced, just couldn't really think of any other inspirational name for this. But you can load an image here. This one is not actually 1024 by 1024, but what it will do is rescale everything to that size all in one place. So really, this is just another efficiency node. I found that I was creating a lot of really messy workflows where I had to have a whole bunch of image resize nodes to bring everything to the same scale. So this is just a way of doing it all at once. If you hook it up to mask, it will follow whatever's in the mask channel here. If you're using a black and white image, it does not matter which one you pick, red, green, blue. They will all work for you. I highly suggest, though, that you use mask preview pretty extensively here, just to make sure that things are what you expect them to be. Latent type, this is just for the empty latent part. It's going to be 4 channels for Stable Diffusion, 1.5, SDXL, all of that, Aura Flow, but pretty much everything that's been released in the last year is going to be 16. So that's your safe default. If you get an error about 4 channels where 16 were expected or vice versa, just try flipping that around. Aside from that, the one other thing that's worth pointing out is there's one other convenient thing you can do here. If you set resize to input, it will override the width and height, and whatever else you hook up here, it will resize it to match that same size. So nice and convenient. All right, so let's generate our first image here. Oops, done fucked that one up. That's because I have nothing hooked up to the mask input. All right, we're just going to delete that for now, just so we can get going on this. It'll take a moment to encode, and here we go. Generate an image with Stable Diffusion 3.5 medium. We're going to use that today because it's really fast, so we're not going to be waiting a lot here. Okay, so a walkthrough of what's available in the ClownharKSampler. This is actually really not that dissimilar in terms of the available options versus KSampler, there's really just a couple extra. So first and most notable is Bongmath. So Bongmath is really a pretty crazy way of accelerating the sampling process that doesn't cost you any CPU cycles, really. It's not going to slow your process down. It's not going to cost you extra RAM. Really, it's just a linear algebra trick that allows things to adjust more rapidly, have less dependence on prior steps. It can search more aggressively through the latent space. It actually does accelerate convergence. So oftentimes you'll need fewer steps overall to get a very coherent image. But sometimes you're looking for that less coherent look, like with some abstract art styles, then you might want to experiment with turning it off. The sampler mode we'll get to in a couple minutes. Sampler name. This is available, of course, in KSampler as well. Big difference here is we have many, many, many options available. It can look pretty intimidating at first, especially if you don't have nested folders set up, which I really recommend you have set up. That's available in the RG3 pack. I've got a link to that on the main page of the repository. But really, the only ones you really need to be familiar with, just RES2M, RES3M, RES2S, RES3S. That's pretty much good enough. Sometimes I will just go through some of these, like if I've picked RES3S and I notice that the image has a little bit of a mutation somewhere or the text is a little off, sometimes you can just try clicking through some of these other ones and they're so similar that you'll get something with the same composition, but some of the details will change. So sometimes you can shuffle things into place by experimenting with it. But really, it's a very empirical process. Regarding the names here, the thing to be familiar with is the ending. So if this says 2M, 3M, it means second order multi-step, third order multi-step, or fourth order multi-step. So multi-step samplers all run at the same speed as Euler, which is the fastest possible sampler, one model call per step. The ones that end with S are multi-stage. They have multiple model calls per step and they will be slower. Just like DP, MPP, 2S, Ancestral, you know how that's twice as slow as Euler? The same thing applies here. It's 2S because there's two model calls. This one will be twice as slow as Euler. 3S will be 3 times as slow, etc. But that's just in terms of the cost per step. They're also a lot more accurate than the other ones that are lower order, so you oftentimes need far fewer steps. Like, for example, find with a lot of models like Flux, 5S is often something that is so accurate you can get away with just 8 steps. And when you're doing really low step counts, you can often get much more unusual images. The one other thing that really is worth pointing out right now that is not present in KSampler, eta. So eta refers to the amount of SDE or ancestral noise that is added at the end of every sampling step. So it's something that allows the image to be corrected during the sampling process. It allows for error correction, allows for more creativity, more refinement. Generally, I've found that 0.5 is a pretty good starting place. You can experiment with setting that to 0. That's like the equivalent of going from Euler Ancestral back to Euler over here. But generally, I just leave that at 0.5. All right, so that's the quick and dirty tutorial on how to use ClownShark Sampler.